Let us learn DC machine. So in DC machine, very first topic, that is construction of DC machine. So this construction is applicable for both motor and generator. So this is basic construction of DC machine. This upper part, outer part is called as yoke, and in this yoke these are the poles. This is pole, this is also pole. I have shown here 4-pole machine. So these poles are bolted with this yoke, and they can be bolted, and this is what field winding which is wound on this yoke. So you can see it is coming from F1, it is wound from this pole to this pole, through this pole, and through this pole it is coming out. And this projected portion is called as pole shoe. And after this, this outer part is armature, which carries armature windings. So these are armature windings. These are armature windings, right? And inside this armature, the brushes are shown. So these are the carbon brushes, and these carbon brushes are on commutator. So this portion is commutator, and inner part is showing shafts. So these are the parts which are shown here. Okay, so let us see what are the parts of DC machine. Parts of DC machines are yoke, pole, field winding. Major parts, we are dealing with major parts: field winding, armature, commutator, and brushes, right? Now let us see these parts. Yoke. So this yoke is made up of solid steel, solid cast iron for small machine, solid cast iron. And if I am using large machine, this is for small machine, and for large machine, rolled or cast steel will be used. Rolled or cast steel will be used for large machine, because there we have to increase permeability for large machine, right? So what is function of yoke? You can see yoke is providing support to these poles, and it is also providing protection of inner insulation from surrounding, right? So yoke is used to support poles, used to support poles. It protects insulation from surrounding, protect insulation from surrounding, and it also provides low reluctance path for field flux. Low reluctance for field flux, right? So this is what yoke. Next part of machine is pole. So these are silent poles. Which are bolted on yoke, bolted on yoke, and field windings are placed on it. Field windings are placed on it. Right? These are made up of cast steel or cast iron. Made up of cast steel or cast iron with laminated construction, right? With laminated construction. So we have seen poles like this, which are bolted to yoke portion. So this is pole, and this portion is known as pole shoe. And what is use of pole shoe? These are used to direct most of flux towards armature. Direct more flux through armature. Through armature to produce more EMF, right? For producing more EMF in armature. Now on this pole we have field winding. So these will be copper or aluminium, right? And they are placed on poles, and they will be excited by DC supply, right? And these windings are connected in such a way that adjacent poles have opposite polarity. Have opposite polarity. How we can see? By the simple winding on two adjacent poles. So these are the two adjacent poles. Okay. This is yoke. So winding is placed here like this. So here current is flowing in this direction, so you can see current is like this, and in this case current is flowing like this. So if I apply right hand thumb rule, the flux direction will be upward here, right? And in this, if I apply current based on the current direction, it is like this. Current are in this direction upward, so thumb will show this direction, so fluxes are here. So here fluxes are coming out from the iron part, so I can say this portion as north pole, and here fluxes are going inside iron part, so I can say this is south pole. So this is how the winding is done on poles to make adjacent poles of opposite polarity, right? Next part is armature. So armature is made up of, again, cast steel, right? It is like this. So these are the slots. These are the slots in which windings are placed, and these are tooth of armature, right? So these slots will carry armature winding, that is armature conductor. Okay, and it will be fitted on shaft. So it is shaft, this is key, this is what shaft, and there will be some holes which are known as duct, cooling duct. These are what? Cooling duct. Okay, so this is what armature having slot and tooth. These are the slots that is housed for armature winding. These slots housed for armature winding. So this armature is fitted on machine shaft, right? Fitted to machine shaft. Okay, and rotate. It is rotating, right? Rotate in field poles, between field poles. Rotate between field poles. The cast steel, that is soft iron insulated laminations, is used for making this, and on the periphery of this is slots are made, right? On periphery of laminated armature, slots are there. Slots are there. What is role of slots? So slots are used to carry armature winding, right? So armature winding, armature windings are placed in slots, and EMF induced, and these armature windings are, what is function? EMF will induced in armature winding when rotated in field flux, so this is generating option, generating operation. Right, the machine will work as generator, and these armature windings carry DC current when connected to DC supply. So it will be motoring action. Okay, the windings can be connected in series or parallel. The various coil will be there, they will be connected in series or parallel. Series will give us, series connection is used for high voltage. We will see how high voltage, and parallel connection for low voltage. And based on these armature winding connection with commutator, they are classified as types of armature winding. They are classified as lap winding and wave winding, right? So this is what armature and armature winding. And next part is Next part is commutator. So this is commutator which is placed on shaft. It has copper segments. You can see these are the segments, right, which are separated by mica sheets. So these are the mica sheets which are acting as insulation. So it is made up of copper segments insulated from each other, insulated from each other by mica sheets, right, mica sheets, and mounted on shaft. This commutator will be mounted on shaft of machine, right? And this commutator is mechanical rectifier. The commutator is a mechanical rectifier which convert AC generated voltage in armature into DC voltage across brush, into DC voltage across brush. Okay. In each commutator, these are the segments, so each segment will be connected with armature conductor. Each commutator segment is connected to armature conductor. By copper lugs or strips, by copper lugs or strip, or they can be soldered also, right? Armature conductor can be soldered with copper segments also. So this is what commutator and how it is converting AC into DC. So for that, let me take two poles, adjacent poles, say north pole and south pole, and I have a conductor. This is one coil or one turn having one conductor on this side, second conductor on this side. Let me name this as 1 dash, and here it is 2 dash, right? And I have commutator segment. So this is brush, and these are connected. These armature conductors are connected with commutator segment. This is C1 and this is say C2. Two segments are there. Mind you, current in this side of coil, say it is upward, so same current will flow here, and this will become plus, and current out will be like this, right? This will be output current at any given position. Now if this coil is rotated along with commutator by 180 degree, so what will happen? This portion will come under north pole and this portion will come under south pole. At the same time, this will also shift by 180 degree. C2 will come here and C1 will come here. So let me show you. This is what north pole. These are what field windings, field winding poles. So field poles are there. They are not rotating; they are stationary. And this is what south pole, and I have this conductor which is rotated by 180 degree. I have commutator segment also, which is separated by mica. Now this is what C2 and this is C1. Brushes are not rotating, they are resting on commutator segment, right? This is one segment, this is second segment, and these sides are soldered or connected with copper lugs. So by 180 degree this will become 2 2 dash and this will become 1 1 dash, right? Now you can see current flowing in the coil side in this conductor under north pole is upward. So whichever conductor is coming under north pole, current direction will be upward only. So here this 2 2 dash is under vicinity of north pole, so current will be upward here, and any coil which is under south pole, current will be downward. So here the coil side under south pole is 1 dash 1, so current will be downward. So current direction coming out of this brush is same, right? But what we are seeing, so at output current direction you can see here coming out from this terminal, and here also, that is at output current is DC. What about at armature conductor? You can see in first position current is flowing from 1 to 1 dash and 2 dash to 2 dash to 2, you can see. And in second position here current is flowing from 1 dash to 1 and 2 to 2 dash, you can see 1 dash to 1 and 2 to 2 dash. So what we are seeing, current direction is reverse. You can see initially it was flowing from 1 to 1 dash, and here in this case after 180 degree it is flowing from 1 dash to 1. That means current in armature is alternating, whereas at output current is DC. So this is how commutator is converting AC voltage or AC current developed in armature into DC at carbon brushes, right? So this is how the commutator is working. Now last part is brush. So brushes are made up of soft material to avoid wear and tear because they are connected at the commutator segment. Soft material which are carbon along with small amount of graphite also, right, with graphite, and these are used to connect rotating commutator to external load, right, used to connect rotating commutator to external stationary load. Stationary load. And number of brushes depends on number of poles also. Number of brushes depends on number of poles. So how many brushes are required, that will be decided by number of pole also. So that's all for construction of a DC machine.